The first chapter that we are going to start for oral histology is enamel. So basically we have all these headings and I'll be covering just the important topics that are needed to understand as well. So first of all, coming on to the histology and the physical properties of enamel. So first of all, you should remember that most of the thickness of the enamel is present on the molars and premolars, very logical point, around 2 to 2.5 mm. Okay. Then there is one more important point. What we see is in maxillary molars, the enamel thickness is more in the lingual surface as compared to the mandibular molars, in which it is more in buccal surface. Okay. Because of this, I think this is just because of the adaptation to the functional demands, the variation. Okay. Now, as we all know, I have been studying enamel is the hardest calcified tissue in the human body. Now, this is important. At the surface, the modulus of elasticity is higher and hardness is more than on the DEJ. Now, specific gravity, you must remember, is 2.8. Okay. Now, the density it decreases from the surface to the deeper regions from cuspal to incisal edges. Now, one more point. Enamel is basically a non-electrical conductive material, and it acts as an insulator at the room temperature. This value I do not think is important, but since values comes often in INICT, so temperature resistance of enamel measured by alternating current impedance, that is the reciprocal of resistance. Spectroscopy is the frequency range. You can just remember it. Basically, think of some value between 5 to 13, and then electrical resistance, क्योंकि it is the opposite reciprocal, 10 raised to power 15 to 10 raised to power 5 ohms. Okay, minus 1, yeah, ohms. And conductances, yeah, ohms, minus 1. So these are basically just general facts. Just we will just come to this one. Just remember this box. Maximum thickness at cusp is 2 to 2.5 mm. Specific gravity is 2.8. Temperature resistance 5 to 13 hertz. Electrical resistance 10 raised to power 15 to 5 ohms. Permeability semi-permeable membrane. Yes, very important. The enamel often acts as a semi-permeable membrane. Okay, it allows the passage of carbon 14 labeled urea, okay, iodine, and so on. Okay, yes. Also, one more thing that I will be covering in clinical criteria, we often see that the staining of the teeth is due to tetracycline during the stages of development in young children also. So most of times people get it wrong. Tetracycline is basically deposited in dentine and not in enamel. So tetracycline poisoning that leads to the pigmentation is because of deposition in dentine. Very small amounts are deposited in enamel. Okay, get this concept correct. So color is yellowish white to grayish white. Then transmission coefficient at 525 nanometer is 0.481 per mm. You can just remember it. Now, very important, chemical properties. Now, as we all know, there are two components. One is the organic and one is the inorganic. For you to remember, the most important thing is inorganic is 96% and organic is just 4%. Okay, now inorganic, as we all know, minerals will come, ions will come, but in organic what will come is proteins. Now organic matter is very unique because it is found exclusively in enamel and lipids, but some of them are also found in cementum, which will come on to later. Basically amylogenin. Okay, so first of all, basic information. Now you must know that organic may we have amylogenin and non-amylogenin. Okay, now amylogenin and non-amylogenin. Amylogenins are low molecular weight and non-amylogenins are high molecular weight. Okay, now very important, think of amylogenin as a mad person. Okay, there's some person who is amylo and he is mad, so we call mad in Hindi as pagal. So pagal. Okay, remember it like this. So P for proline, G for glutamine, H for histidine, and L for leucine. Very often question comes from the amino acids that are present in amylogenins. Now in non-amylogenins, since it is high molecular weight, so someone is high molecular weight, so just a thing to remember, I know it's funny, remember gas. Okay, so basically he has high molecular weight, so more chances of having gas. So G for glycine, A for aspartic acid, S for serine. Okay, very important. You must remember these mnemonics and these will help you. Okay, so and also they are hydrophobic. Now coming on to the inorganic material, we all know that it is made up of calcium hydroxide, hydroxyapatite crystals. Very important, just remember this formula. C10 PO4, basically calcium में you have 10, phosphate पे you have 6 and hydroxyl पे you have 4 and 2. Okay, now hexagonal in cross section. Now, when you see in longitudinal section, they appear as triangles. Very important. See this one. The central core is often made of hydroxyl ion, is always made of rather, and then the calcium ions are in form of triangles and phosphate also. Okay. Now, very important is to know that during formation, magnesium can replace calcium. See. Here you can observe magnesium can come, and over here you can see that it can be replaced by carbonate. Because of these reasons, they are more susceptible to caries. More susceptible to caries and acid dissolution. Basically acid dissolution, then only caries will occur. Okay, this is the important point that you must know. So I've highlighted also. If the core is richer in magnesium and carbonate, then greater solubility in acids than the peripheral portion. Okay, during the formation, so that is why there are more chances of caries. Okay, carbonate rich crystals are preferentially attacked by acids and caries. Okay, so there is one more line that I've underlined is enamel proteins do not contribute to structuring of enamel, which we will understand later in the amelogenesis part and the life cycle of ameloblast. Okay, so one more point. An enamel matrix mineralization begins immediately after it is secreted, and that the acha, yeah, there is this graph that you must know about. This this graph is basically composition of volume of mineralized tissue in which odontoblast processes have been replaced by. So basically in this graph you can see lag phase of dentine is more than bone. Okay, first point to remember. Second point is mineralization starts as soon as enamel is secreted. Around 30% of the enamel is already mineralized in the first stage only. Okay, first point is this. Second point is the lag phase of dentine is more than the bone. Okay, so see bar graph. Okay, the origins. Okay, on the left कि enamel matrix mineralization begins immediately after its secretion. फिर lag in mineralization after matrix bone formation is greater in dentine. Dentine ऊपर था, dentine than bone. Okay, then yes, enamel primary mineralization and the secondary mineralization, they show a very smooth curve. Okay, now also curve में over here also there is primary and then there is secondary mineralization. Okay, so flatten in secondary mineralization, ठीक है, but in rapid it is in primary it is rapid. So this is primary only mineralization and this is secondary mineralization. So this is basically, just erase it. So mineralization. So over here what you see is rapid accumulation. Over here you see a flattened curve. So slow accumulation. Okay, this is just what you need to know for graph. The boxes in urban are very important. Inorganic, I told you 96%, mainly all the ions. Now in pulse there is a question asking ki which ion is absent in enamel. So remember magnesium, I already told. Calcium phosphate we know will be there. Oxygen also you have to remember. Sodium and carbon very important. Remember no fluoride. Okay, so hydroxyapatite this. Organic is 4%, I told you. Amelogenin, non-amelogenin. Yeah, very important point is enamel में there is no collagen. Okay, amelogenins they are hydrophobic, low molecular weight. Okay, now pagal PGHL. Non-amelogenin basically high molecular weight, so person is going to have gas. So glycine, aspartic acid and serine. Okay, I hope I made it easier. So now coming on to these were the physical and the chemical properties. In next video we'll understand the structure.